Here we have a problem in algebra 2, that is we have to solve for x in the given rational equation. Okay, my first step what I'm going to do is I'm going to simplify the expression we have on the left side of the equation. So that is I'm going to do subtraction between the fraction 2x over x positive 7 and the integer 1. Okay, whenever I want to do addition or subtraction between a fraction and an integer, what I have to do is I have to multiply the integer by the denominator of the fraction. Once I'm done with this multiplication, I can take this x positive 7 as a common denominator. Okay, let me do it. So that is 2x negative. I multiply this integer 1 by the denominator x positive 7. Then I'm getting 1 times x positive 7. Now I can take x positive 7 as a common denominator equals to negative 10x positive 70 over x square negative. So this 49 is a perfect square. It can be written as 7 square. So why should I write this 49 as 7 square? There is a reason. Let's consider an algebraic identity, that is a square negative b square equals to a positive b times a negative b. Okay, here we have difference of two squares. Whenever we have difference of two squares in this form, a square negative b square, it can be written in the factor form, that is a positive b times a negative b. So in order to get this expression x square negative 49 in this form a square negative b square, I am writing this 49 as 7 square. So now this expression is exactly in this form a square negative b square. In my next step, what I can do is I can write this expression in factor form, that is in the form a positive b times a negative b. So comparing this and this, at the place of a we have x and at the place of b we have 7. So when I write this expression in factor form like a positive b times a negative b, so at the place of a I have to plug in x, at the place of b I have to plug in 7. Then the factor form of this one will be x positive 7 times x negative 7. Okay, let me continue the next step. So here we have 2x. Now what I can do is I can distribute this negative 1 to this x and positive 7. So when I do so, I'm getting negative x negative 7 over x positive 7 equals to negative 10x positive 70 over. So we can write this one in factor form, that is x positive 7 times x negative 7. Okay, now my aim is to get rid of the denominators on both sides of this equation. Once I get rid of the denominators on both sides, then the fraction will be no more and I can solve for x easily. Okay, when I look at the denominators over here on the left side and right side, I see that x positive 7 is a common factor. Okay, so if I multiply both sides of this equation by x positive 7, I'll be able to get rid of this denominator completely on the left side. And in this denominator, I'll be able to get rid of this particular factor x positive 7. Okay, now I'm going to multiply both sides of this equation by x positive 7. Let me do it. So here x positive 7. Okay, the x positive 7, x positive 7 will cancel. Here the x positive 7, x positive 7 will cancel out. And the resulting equation is, to get the resulting equation, what we can do is we can combine this 2x negative x, and I'm getting x negative 7 on the left side. And the right side we have negative 10x positive 70 over x negative 7. Okay, still we have denominator on the right side, that is x negative 7. So to get up this denominator x negative 7 on the right side, what I have to do is I have to multiply both sides of the equation by x negative 7. Let me do it. So when I do so, this x negative 7 will cancel out. And now on the left side, I can multiply these two binomials using the FOIL method. That is, first I have to multiply the first terms, x times x is x square. Now I have to multiply the outer terms, x times negative 7, it will become negative 7x. Now I have to multiply the inner terms, negative 7 times x is negative 7x. When I multiply the last terms, negative 7 and negative 7, I'm getting positive 49 equals to, on the right side, we have negative 10x positive 70. Okay, we have x square. When I combine this negative 7x and negative 7x, I'm getting negative 14x positive 49 equals to negative 10x positive 70. Okay, now what I can do is actually we have a quadratic equation over here in the variable x. So to solve this quadratic equation now for x, what I have to do is I have to write the quadratic equation standard form. So standard form of a quadratic equation is we have to get all the terms on one side of the equation, on the other side we must have 0. Here let me try to make the right side 0. For that we have to get rid of this negative 10x and this positive 70. For that I am adding 10x to both sides. Let me write it. And also I subtract 70 from both sides. Let me write it. So here the negative value, positive value cancel out, the same thing here. And we get x square. When I combine this, I'm getting negative 4x. And when I combine this, I'm getting negative 21 equals to 0. Okay, now we have the quadratic equation standard form. I have to solve for x in this quadratic equation. I think this quadratic equation can be solved by factoring. For that, what I have to do is I have to multiply this constant of negative 21 by the coefficient of x square. In this case, it's just 1. So when I multiply this constant of negative 21 by the coefficient of x square 1, still I'm getting negative 21. Okay, now I have to get two factors for this negative 21, so that the product of the two factors equals to negative 21 and the sum of the two factors equals to the coefficient of x, that is negative 4. I think negative 7 and positive 3 will work. When I multiply negative 7 and positive 3, I'm getting negative 21. When I add them, I'm getting negative 4, which is the coefficient of x. Okay, and also before to get the two values of x for this quadratic equation, I have to divide both these factors by the coefficient of x square, that is 1. So when I divide negative 7 by 1, still I'm getting negative 7. When I divide positive 3 by 1, still I'm getting positive 3. Okay, now to get the first value of x, what I have to do is I have to change the sign of the first factor over here. It's already negative. When I change the sign, I'm getting positive 7. So that's the first value of x. Okay, now to get the second value of x, I have to change the sign of the second factor. Already it's positive. If I change the sign, it will become negative. So the second value of x is negative 3. I solved this quadratic equation and I got two values for x. One is 7 and other one is negative 3. Okay, here we are solving a rational equation. Okay, whenever I solve a rational equation, the solutions I get at last, we cannot consider them as valid solution immediately. So always we have to verify the two solutions with the given rational equation, particularly with the denominators of the given rational equation. So we have to make sure that the solution we get over here should not make the denominator in the given rational equation as 0, because if the denominator becomes 0, then the value of the fraction is undefined. Okay, now let's verify these two solutions one by one. First, let me verify the first value of x, that is x equals to 7. So for that, I have to plug in x equals to 7 in the denominators of the given rational equation. If I plug in x equals to 7 over here, I'm getting 7 positive 7. Anyways, when I plug in x equals to 7, this denominator does not become 0 because 7 positive 7 is 14. Okay, now let me check with this denominator. When I plug in x equals to 7 over here, it will become 7 square. 7 square is 49. 49 negative 49, it becomes 0. So the first value of x, that is x equals to 7, makes this denominator 0. So when this denominator becomes 0, the value of this fraction is undefined. So since x equals to 7 makes one of the denominators in the rational equation as 0, we cannot consider this x equals to 7 as a valid solution. It is an extraneous solution, so we can reject it. Okay, now let's verify the second solution, that is x equals to negative 3 over here. So for that, we have to plug in x equals to negative 3 into the denominators over here. Let me plug in x equals to negative 3 into the first denominator, x positive 7. So when I do so, I'm getting negative 3 positive 7. So when I simplify this one, negative 3 positive 7, I'm getting positive 4. Anyways, it does not become 0 when x equals to negative 3. Okay, now let me check with this denominator. When I plug in x equals to negative 3 over here, negative 3 whole square is just 9, negative 49. Which is equal to negative 40. Anyways, so when I plug in x equals to negative 3, this denominator does not become 0. So the second value of x, I mean the second solution x equals to negative 3, does not make any of the denominators in the given rational equation as 0. So we can consider this one as valid solution. Therefore, the solution for the given rational equation is x equals to negative 3.